as a technical account manager for HashiCorp. So I do kind of post-sales stuff. So anything to do with customers, I kind of work directly with them on support issues, feature requests, roadmap, and that kind of stuff. I'm basically the main technical contact for basically anyone who's paid money for HashiCorp stuff. But obviously, it doesn't mean that I don't care about non-paying people. I still have been in the community for a while. I've been using HashiCorp tools since probably Vagrant in like 2011. I previously worked at Puppet. I've been involved in open source and even CfgMgmtCamp. I've been coming since about 2014. Last year was the only year I've missed because I just had a baby, so it was a little busy at the time. So I managed to fly over to Brussels for a quick talk and foster them and come straight back. Cool, so a quick primer on why Golang was invented. So it's a pretty good blog post. Oh yeah, and by the way, all the slides will be available after that. I put a lot of links in this. There's a lot of examples, so don't worry too much about trying to, look through and click through links or anything like that, because the slides are available after. So, it's a pretty good kind of summary talk, and there's been a lot of, if you just Google, the history of Golang, lots of people have talked about it. The kind of more official Google line was, it was designed to make working modern infrastructure more productive. There's a little bit more politics behind it with the kind of big Oracle versus Google Java thing with the interface, and they kind of went with there's a Google kind of idea they should move away from Java because they were worried about that. There was the idea they wanted to have something that was basically C++ with bells on, which is why quite a lot of Golang kind of feels that way. But it's, any language that's designed by one of the largest tech companies out there is inevitably going to be pretty big, but I think the features of it have kind of proven itself and made it pretty cool. So why is it kind of popular in the DevOps world? It's a compiled binary, making it a lot easier to get it onto a system. If you look at how even something like the Debian spec files, it all kind of builds itself, because at the end of it you just got a binary that works on certain platforms. It's quite easy to distribute. You don't have to worry about installing Go onto a machine. Since 1.6 or 1.5, Go can compile itself with Go, so you don't even have to worry about C binding, things like that. Platform independent, it pretty much builds everything you can think of. I remember reading a GitHub issue about trying to build, the only one I can think of that's still kind of around was probably building Golang on AIX, which there's some guys at IBM still trying to tie this point, but they're getting closer. Static type checking, so if you're into the ability to make sure that your types are as they expect, they're pretty good for that. It's super fast in terms of standard benchmarks. There's some pretty good examples of it compared to other frameworks and tools. The CLI libraries are really good. I don't know if that's a chicken and egg thing where people started using Go for CLI apps, so then the libraries got really good. HashiCorp has their own CLI library, which we use for all of our tools. Plus there's things like Cobra and Kingpin and a few others. Plus it's quite easy to write your own as well. And yeah, it's kind of like everyone else was doing it. It's again, it's a kind of chicken and egg thing where its success was almost inevitable because Google were making it, but I think the features that came with it really did help out. And yeah, there's a lot of kind of tools that are used in the kind of DevOps world that are Go related. Obviously this isn't an exhaustive list, but this is kind of one I can think of off the top of my head. And then obviously as a company like HashiCorp, most of our tools are written in Go. So the funny thing was, I jokingly put coming soon into Vagrant, and I put my slides into the HashiCorp Slack to kind of get some feedback from people within the company. And Mitchell pointed out that technically Vagrant already has Go bindings in it, because there are weird little edge cases that Vagrant has to hit, which they used to share out to various shell scripts and tools. And since then, they've actually started turning those into little Go binaries that can be distributed with Vagrant itself. So technically, Vagrant is already a Go app in certain ways. And actually, one of the funny things was when I mentioned everyone else was doing it bit, Mitchell kind of called me out on that because he said, well, technically at the time, no one else was doing it because when we first started using Go in Packer, it was about, 2012, I think. And yeah, a lot of these tools didn't even exist. But his kind of point is that Go is painfully pragmatic. It's kind of it doesn't do everything perfectly, but it does everything okay, and that kind of is pretty good in terms of language, really. One of the analogies that one of the other engineers said was that he says Go is like khakis, like the trousers, which is no one ever says khakis are the most amazing trousers in the world, but everyone wears them and they're kind of the most neutral standard trousers to wear. So he said Go is like the khakis of programming language. I don't know if that's a ringy endorsement or not. So yeah, so because of that, because a lot of the there's a little bit of a big bet on Go, if you look up especially when you first start writing Go, you'll probably notice that a lot of the Go libraries, especially for CLI or low-level bindings, are pretty tied into the HashiCorp ecosystem. So Go HomeDir, which is like the most popular library for figuring out what your home directory on your system is under the HashiCorp namespace. If you look up a lot of the Go libraries, a lot of the most popular Go libraries are under either the HashiCorp namespace, Armon, who is the co-founder of HashiCorp, or Mitchell, who's the other co-founder of HashiCorp, which is kind of fun. So I've kind of had a little bit of a cheat because I can just talk to people internally about a lot of the Go questions I have. Yeah, hopefully, even if you don't have Go within your company, you should be able to do that as well. So yeah, I kind of had this feeling of like, I've been kind of playing around with Go on and off, and then when I started at HashiCorp, I was like, okay, let's dig into this deeper, because I like being involved in the community and opening pull requests and things like that. So let's learn this thing and figure out how it goes. So I consider myself kind of a glue developer. So I have more of an ops background than dev. I'm more kind of a person who does, my code writing was more in kind of infra as code rather than kind of straight code writing. I am a Rubyist, or at least I was for a while. My experience was more on the scripting side. Even the Ruby that I wrote was generally for a script or kind of tiny little goodish fixes if things needed to happen. Like I have some code in Puppet, but nothing like, no huge feature written end to end. It's more like I noticed a little problem and I knew enough Ruby to change that problem to that. So who else here considers themselves kind of like a glue developer? There's a lot of hands. So. Cool. So hopefully, you're going to see my point of view and think that, hopefully you're in the same sort of spot here. There's a really good, I don't know if this phrase translates into non-British English, but there's an idea of I know enough to get into trouble, which is like the idea that you know enough to get yourself into a bad spot, but probably don't know enough to get yourself out of the bad spot, which is where I think I am in Golang terms now. Yeah, and then there's a classic meme of the dog trying to do some science and saying, I have no idea what I'm doing, which is how I kind of feel about Go a lot of the time. So, we've got about 25 minutes, although I was given an extra 5 minutes leeway. I don't want to cut into too much of your lunch. But obviously there's so many bits of minutiae about Go, and it's not something that I can cover the entirety of in 30 minutes, of which we'll probably go into like 5 or 10 now. But let's go through the things that stuck out to me the most as a glue developer, and since most of the room consider themselves glue developers as well, hopefully they will work with you as well. So there's a really good blog post which is kind of like Go for Rubyists, and I apologize for anyone who's not a Rubyist here, but hopefully you can kind of see the ideas, because obviously Ruby and Python are fairly similar in some of the interpretive language kind of things. So variables. So in Ruby, you have what's known as duck typing, which is the ability to infer a type based on the data you're giving in. Depending on the type you're trying to create, sometimes it's actually impossible to define exactly that you want this type over something else. You can do something like integer 1, and it'll definitely be an integer, but generally you're just going to see people do a equals 1 because Ruby is going to be clever enough to go, oh, it's an integer, that's fine. But it doesn't work that way in the Go world. You actually have to give the type of a variable that you're defining. The funny part is that even though Go is a statically typed language, it kind of feels dynamic because it has this little, kind of the name of it, but this colon equals kind of syntax, which is kind of doing a little bit of inferring, but unlike Ruby, you won't be able to change that type later on. So in this example, we've set the variable a to be 1, we can then set it to be hello later on, changing it from not only changing the value, but changing the type from an int to a string. That's not possible in Go. So if I set a to be 1, and then I try to set a to be 2, that's fine, it's the same type, you can reassign the variable. But then if I try and change a to be hello, that's not fine, because the compiler will actually complain and say, hey, this is a type int, this is string. So anyone who's come from a kind of stronger type background will probably already know this stuff, but it was fairly new to me as a kind of Ruby developer. So yeah, most of this will still look pretty similar. Hashes in Golang are called maps. They pretty much get assigned in the same way. In this, I'm creating a hash by saying conf name, CfgMgmtCamp, location, and then to do a lookup, I just go location hash location. It's slightly different because Golang is statically typed, I have to say not only what is the field for the thing I'm looking at, but what's the content of that field. So I'm saying this is a map where the name of the key is string and the value of the key is going to be a string as well. But other than that, it kind of works the same way. So where it gets a little bit more difficult is arrays. So in Ruby, I don't have to define the length of the array when I create it. I can, but again, it's strongly typed a lot of the time. Whereas in Go, I have to actually define a length of an array when I create it. We can actually be lazy and let the compiler do it for us by doing ... So in this case, it'll go, oh, you've given me 3 elements, so I have to do it that way. But you know, the world isn't like this a lot of the time, especially when we're dealing with unknown data sets. We're probably going to be not knowing exactly how long the array is going to be. So how do we do that? So this is when you start talking about slices, and this is when, as a Ruby person, you start getting a bit more comfortable because you're directly dealing with out-of-memory errors or out-of-index errors, I should say. So there is a method in Golang called make. It's actually used with a few other types like map as well, but in this example we're doing talk about slices. Inside there you'll be defining what the slice type is, and then followed by the default length of it. You can also add a cap for the length as well. And then as you use that slice, you can start adding stuff into it. So in this example, I'm setting first element, the second element, and the third element. Well, it's a zero-based array. But then obviously, if I try and say S3, this is only length 3 right now, so it's going to give me a padding and say index out of range. So in this example, to actually add something to it, I will use the append method. So what the append method is doing, it's a helper method. It takes the original slice. I can't remember if it doubles the size or just adds 1 to it. I can't remember the exact one. It will double the slice, add the new element in, and then return back the new slice. So you're not actually increasing the size of the original slice, you're making a new slice and then returning that back. Which is actually quite interesting when you start thinking about memory management. So this is the example they actually give. This might be a little bit too small for the guys at the back. But this is the example they actually give in the Golang docs, which is, I've got a pretty simple method here. I'm going to read a file, and I'm going to regex that file for a certain regex that I'm giving it. The problem with this is that this slice is a slice of the entire contents of the file that I've looked at. And that's going to be hanging around waiting to be garbage collected. So let's say you're opening, probably should be doing this, but let's say you're opening a 200 megabyte text file. 200 megabytes of memory, obviously on a modern system isn't that bad, but obviously if it's just hanging around, you're doing this over multiple files, lots and lots of time, you're going to quickly run out of memory. So the example they actually give is you actually create a new slice, you then copy the elements of the lookup from the slice into a new element. That means the original slice can be returned, can be garbage collected and let out, and then you're returning that there. So it's the kind of thing that you don't really have to think about memory management too much in Golang, in Ruby, sorry. But it's the kind of thing you have to start thinking about in Go. And the other thing that's kind of funny to start getting used to when you start using Golang is unused variables, and that includes imports as well. So Ruby is completely fine with just having a bunch of stuff that you left behind. So in this example, I'm saying A is 123, I'm saying B is 123, and I'm saying puts B. Ruby's fine with like, oh, you never used this A, but I don't care. It's not, you can't do that in Golang. If you don't refer, if you create a variable or you do an assignment to a variable, and then you don't use that variable, you'll get a compile error saying, hey, you made this thing, you never looked up for it. So there is a underscore reserved variable. That means if you have to have a method that has to get a return from something, just ignore it. So in this example, the way that ranges work, which is kind of a look through an array or a hash, is the first element will be the index, and the second element will be the contents of that variable. So in this example, all I'm trying to do is loop for a slice and add all the elements together. So I don't care about the index. So to do that, I'd have to use this reserved underscore variable. And yeah, you probably see this most often when you do it at range. Technically, there's quite a big pattern with Golang where when you do a method lookup, and we'll talk about the error is nil thing later on as well, it generally is going to return 2 things, an error and then the return of the thing you're trying to look up. So technically, you can just assign that error to an underscore and then completely ignore it. The problem will be, in this example, if I'm trying to do this lookup, if this path does not exist, then the entire thing will crash because it will try and do a memory assignment to a bit of path that doesn't exist, and the whole thing will crash, which is where you get into the weird thing with error is nil and how errors work in Golang. So there's kind of an ongoing in-joke with error is nil in Golang, because you end up writing a lot of code that kind of looks like this, where most of the methods you'll be using in Golang will have a return value plus an error. And generally what will happen is in that function that you're doing a lookup from, there'll be some code that goes, is this index out of bounds, then return error, is this value invalid, return error, blah, blah, blah. So it's going to return an error. If there's no error, it returns nil. So then you end up having to write a bunch of code that says, if error is nil, do whatever you need to give that error, which has ended up with kind of memes that kind of look like this. So one is the touch bar on a Mac with a dedicated error is nil button, and the other is having a dedicated error is nil button on the keyboard. And there's a funny attitude about this. So kind of talking to people as someone who's from a Ruby world, I really don't like having a bunch of kind of repeated code. But there's almost a feeling of like, it's a good thing in the Golang world. And again, I'm not sure if this is just a difference between how I feel about this. I've just worked in such a different way. But generally there's a feeling of like, yeah, that's fine. Or it forces you to think about how your code is being written and how errors are being handled. It means that you can't just kind of like do a raise exception and just hope that the thing you're doing, the raise you're doing within the exception is fine. There is try catch raise in Golang, but most people will say don't use it in your code. Let the low level libraries handle that. And every time I've asked a Go developer about try catch raise, try defer raise example, they say don't do it. And there's actually even linters that will actually lint through your Go code and say, oh, you've done this, don't do this. So one of the things you can make it a little nicer is if you don't care about, if you're not trying to get a lookup value, you're just trying to check if a function returns an error, you can loop it into this slightly easier bit of code. So in this example, I'm doing something neat, but this method doesn't return a value, so maybe I'm trying to trigger an API, but I don't have to wait for a return value. So as long as the error is nil, as long as the error is not nil, then the rest of it will be fine. The problem with this approach is that if you do want to return value from this, the return value from this will only be available in this scope here. So you can't use it in the rest of the code. So all hope is not lost if you're looking for a slightly nicer way of doing things. This is super early. So this is the example of giving more context. So the other thing people say is don't just return don't just return error. Give an error that gives context of what the error is. So errors are literally just an interface with a return of string. So it's very easy to extend the interface and add in more details. So the example they give is from the JSON Marshall library for looking up JSON files. So what they do is they have a standard error, just takes the error message, but also has an offset. So in this it's saying if there's a JSON syntax error, if you can find the offset, add that to the error as well. So it's like this line is the problem. Whereas if the error was the file doesn't exist at all, it would just return that error normally. And there's also a library that is currently, I think there's one in core and one there's a few maintained called wrap, and that will give you the kind of more full stack trace. So if you need to find out where the error came from in terms of the line of code, or if you really care, the full kind of memory stack of why it happened. This is way out of my purview, but you can actually wrap the error and say like, this is where the error is from, this is what the memory stack looked like when it happened. And yeah, I thought about taking this slide out because I've had multiple arguments about this with people, but it's possible to write kind of helper methods to make the errors a little bit easier to do. So if you have a bunch of errors that are kind of giving the same way, you can kind of make a helper method that just goes loop through all the errors, and then if there's an error in there, return that. But then that only works if all the errors are giving the same type of error. But again, a lot of the time people are like, don't worry about it, that's just how Go works. So there's a kind of new approach that's happening in Go 2.0. Obviously, it's a long way away. This is still in the draft stage, but essentially it's kind of turning this, it's trying to dry up that code a little and having this new check handle kind of language. So what this does is it goes handle the return of an error, and then you can put whatever code you want in there. Generally, this is going to be return error. And every time you have some code that has a check to see what that return is, then you do these check loops of it. Obviously, that's quite far away. We're still only on Go 1.13. So, IDEs for beginners. My personal favorites, obviously there's Vim people out there, Emacs people, whatever you want to kind of talk about. But as a newbie, I generally like, I always get this, actually I think it's Visual Studio Code, right? I got the wrong around. Yeah. Visual Studio Code or Golang. Golang is the JetBrains Go IDE. So if you want to go really hardcore and have like a bunch of like helpers and methods to tell you what's going on, it's pretty good. It's a little bit too heavy for me, but it kind of helped me understand how debugging works in Go. Whereas the out-of-the-box experience for Go in VSC is also really good. Let's see if this animated GIF actually works. Might be a bit too small for people at the back. Let me wait for it to load. So, I'll loop around. So the cool thing is in Visual Code Studio is if I add in a certain method or a lookup for a package, it will automatically import that, and it will do it vice versa. So if I delete some code, it will automatically delete the lookup and the variables as well. Which is pretty cool because, as we said before, Golang will automatically not compile if you, it won't compile if you have variables that you don't refer to later on and imports. And the out-of-the-box experience for things like macros and helpers and doing debugging and delving is all pretty good. One of the cool things is if you're running a test in Unused code, it comes up with the little helper methods. So you just click the button, it runs just that one test for you, which is pretty cool. And packaging. So packaging has had a long and storied history in the world of Go. It's not really packaging in the way that I understand it. There's no package manager per se. It's more like vendoring in terms of you are cloning code from repos from the internet. And obviously there are kind of more like a binary format if you're downloading from go.package.in or maybe if someone's got their own Go repo. But the Go mod is kind of the newest approach that that Google have taken. Bear in mind there have been like maybe 2 official and 6 or 7 kind of community ones that have been picked. So one of the good things about Go mod is it actually will convert from previous approaches, which are Glide, Dep, Go Vendor, and the kind of core one. So it's quite easy to use. I only just started using it recently. It's pretty good because you don't have to worry about your project code being under the Go path. There's no fun thing about Go is that you have a Go path where everything is looked up from, for when it does compilation, to go under your Go path and do all this kind of stuff. It's the kind of thing that really confused me when I first started, but with Go mod you don't have to worry about that. The previous blessed approach before Go mod came out was Dep, which is more, it feels more programming, package managery. You would run Go Dep in it, and it would go fetch stuff and then put it into a vendor folder in your code. So you can then compile it without having to have all of the packages on your Go path. Cool, so yeah, we don't have a huge amount of time, there's a bunch of other stuff. Funny enough, I originally said the reason I don't talk too much about new texts and channels is I don't understand too much, but then over FOSDEM and talking to a few other Go people and people internally at actually reviewing my slides with me, I understand it a bit more. So because Go is such a popular tool for networking and for kind of running as a daemon and having it kind of talk to various systems, a mutex is just a lock. So if you're having some code that is being run on multiple cores and run in parallel kind of thing, you probably want to lock certain things so things don't clash. And deferring is actually pretty good because all it means is that method won't happen until the end of the method that it's in is completed. So the most common one I've been using deferring with so far is in tests. I'm setting up a little HTTP server, and inside the test I'm hitting that server and getting some responses, but then I'm doing a defer like HTTP server.close. So after the test is done, it will automatically close the connection there. So, but again, honestly, most of the time, if you're asking me questions about these, you know more about them than I do. So, so a real life example. One of the kind of reasons I wanted to learn Go stuff is I wanted to contribute towards some of the internal HashiCorp tools. So I actually had this ask from a customer. They were using the GCP auth backend in Vault. People not super familiar with Vault, it's a really popular security tool. One of the auth backends is the ability to give secrets based on authentication based on GCP metadata. So previously it was only using the kind of more persona-based authentication. We added in the ability to use system-based authentication, similar to AWS, where you say like, if this system is in this region, then I can look up this secret or get this key or whatever. As part of that, you can bind zones, regions, instance groups, and labels. So you can say, you're only allowed to get the secret if you're in EU West 1, you have this label, and you're bound to this kind of group. So honestly, because there's quite a lot of schema and approaches in Terraform, it was quite easy for me to implement, because it was pretty much the case of looking at what already existed and then changing a bit. So there was already a bound service accounts schema, so we just renamed that to be bound zones. And then this is all of the rest of it is kind of templating and scaffolding that comes with Terraform itself. And then in the code itself, we want to be able to add the lookup from the API to the schema. And if you look at this, it looks very familiar than the approach we were talking about earlier on with is nil. So in this example, we're doing d.getOK. So all this is doing is the d is a schema of all of this stuff it gets back from the API in GCP. get OK returns two values, the value and OK, which is actually an error, so it's just saying value and error. If OK is OK, then we add bound service accounts to the schema as a list. All pretty good. And then we just have to do that 4 more times for all the extra values that we wanted to add in. So there, we just changed it to bound zone. Ta-da! We're Go developers now. So this was the PR I made. I didn't really know too much about how to do testing in Vault. The testing in Vault is actually quite a lot of more acceptance than unit, because you're literally writing out, the test will actually write out a Terraform, some Terraform code, and then run Terraform on that code as part of the test and see if it returns an error. The Vault test will actually spin up stuff and bring them down again. So for this test, there's actually a bit that says you can add in your GCP environment variables to actually talk to GCP. So all I did was just write some code where I added in those new values, test passed, everything's great. Woo. Obviously, it's not really learning too much. We're kind of skating around on here. We want to kind of flex our Go muscles a little bit more. Because whenever you're kind of learning a new language, if you're using an existing repo, a lot of the hard work is done for you already, especially around testing. So let's start from scratch. So one of the things I mentioned, and this is one of my big approaches when learning Go, I really think writing CLI tools is really good, especially for something that you personally need, because it gives you a little bit more simple cleanup of repos. I work for a lot of Git repos, and they have quite a lot of branches in there. All I want to do, list branches that have already been merged into master, and give the option to delete that branch. So write some pretty simple Go code. First, I'm using the OS library to get the current working directory. This one, I actually tried multiple times to try and figure out how you would get this error. Because even if you delete the directory that it's running from whilst it's happening, it still refers to a directory. If you try and do anything after that, it will break, but that's not. So theoretically, I assume there is some way of doing that. Maybe you're running a container or something like that. I guess. Yeah. Do you mean like masking or something like that? Yeah, I guess so. But I couldn't figure out how to break it, so I have to set them in that test yet. Then I use the Git library to open the current directory you're in. Then I return an error if you're not in a Git directory for some reason. Then I do repo.branches. Again, if there's no branches in there, it's going to fail. Then we get into some slightly more meaty code. So first, I'm doing a range of the branches that are given. I'm then going through the log from master, and then iterating through and finding all of the heads of the branches I've got from master. If they're contained in there, they've been merged in, so then I can list them, and then I can actually run git.delete on that. Again, we're done. I've made this little Git super CLI tool, and now I'm a Golang developer. Oh. The fun of Unicode emojis. That is known as the male technologist. Depending on the emoji support you've got on your system, it will show or not. But that's like the little guy's little laptop. And yeah, so we moved from dog at the science kit, not knowing what he's doing, to knowing exactly what I'm doing. So in conclusion, just a quick run through Go. If I can do it, anyone can do it. I'm not like some super skilled engineer. It's quite easy to get off the ground with Go, and I recommend it. It's being used by a lot of DevOps and config management tools right now, so it's good to learn. Get your hands dirty, try making a CLI app, or submit patches to favorite tools. We actually have a really cool contributing.md that we use for all of our HashiCorp tools, which is you will never be told off for opening a pull request. Like, you might get told off if you start being shirty with us in the comments, but generally, if someone's contributing towards our software, we appreciate that, and we will try and guide you to getting it working. So don't wait until you've got it perfect and you've got all the tests worked out. Someone will definitely try and help you with some of the code. Doesn't mean it'll be done immediately, because we're pretty busy right now, especially with 0.12, but we always want to try and help. And yeah, there's some great resources out there. As I said, the slides will be available. These are the things that I've been using. The little Go book is really good and free. The intro to Golang book is also free. The Git by example is really cool. It actually has a little REPL that you can run Go code in. The Golang tour itself is really good for learning. And if you're interested in particularly Go for writing providers or contributing towards core Terraform, there's a extended doc on how to do it. And there was a great talk from HashiConf last year by someone from DigitalOcean who wrote Terraform providers for some weird stuff like Google Calendar, Todoist, Jira. He was just proving how easy it is. And even a think light switches as well, using like smart light switches. So it's very easy to do. The schema stuff does a lot of the work for you. It's just a little bit of learning how to kind of glue that all together. And we are glue developers after all. Thank you very much. Cool. So eating into a lot of lunchtime. So if there's any questions, probably come up and talk to me. Everyone else, Newbie? Thank you.